Another application or analogy of propositions would be logic gates. So, logic gates are abstractions of electronic circuit components that operate on one or more input signals to produce an output signal. Now, most computers are still working with the binary language, which means the values would either be a 1 or a 0, depending on the code. Now, logic gates processes these signals to produce an output signal for whatever purpose it may serve. Now, we are going to look into three basic logic gates. We have the NOT gate, or the inverter gate, the OR gate, and of course, the AND gate. Now, these are analogies to our logical connectors. As their name implies, the NOT or inverter gate is for our negation operation. Our OR gate is for our OR or disjunction, while our AND is for our conjunction. Because of this setup, we can then parallel analyzing basic logic gates to how we analyze our propositions. Let's have an example. So we are asked to determine the output stream for the following diagrams. Let's take a closer look into these diagrams. Alright, there we go. So, we have here the input streams, and then we are asked of the output stream. Now, let's analyze the specific logic gates that we have here. As we can see, we have here our NOT gates. Although you might have noticed there's no circle on top of the triangle, but some NOT gates are drawn like that, some are drawn with a circle. And then we have here our AND gate, which would mean once our inputs goes into our NOT gates, our NOT gate would have to negate that specific input, and that specific input, which is negated, is now the output of the NOT gate and becomes the input of the AND gate. For example, let's just bring that down. Let's fix it here. So, my input here is 1, then I have another input of 1. Going through the NOT gate, let's NOT gate, our input of 1 becomes 0 and our input of 1 becomes 0. This in turn becomes our input for the AND gate, and we know that 0 and 0, 0 and 0 produces an output of 0. That meant in the output stream, the first output that we actually have here is 0. That's how our logic gates basically work. Let's now try on the others. So we have 1 and 0 as our inputs. So let's change this one here. Because I already know what it does to 1, I'll now change this to 0. So NOT 0 is 1. Therefore, here we're going to have 0 and 1. 0 and 1. And we still know that 0 and 1 is 0. So therefore, the second output in the output stream would still be 0. If we're going to interchange the two, will there be a change? Let's see. So let's erase first these ones here. There you go. So our input on top is 0, input below is 1, not 0 is 1, not 1 is 0, so I'll have 1 and 0, which is still 0. So our third output in the output stream would still be 0. Now, what if we both have zeros? I am not going to change the one on top anymore. So there, so both zeros, not 0 is 1, so we'll have 1 and 1. And here we have a different output, which becomes 1. So, based on these input streams, once placed into these combinations of logic gates, then we have the output stream of 0, 0, 0, 1. A combination of these logic gates would usually be called a logic circuit. So, when we analyze input and output streams for logic gates and logic circuits, we can parallel them to our propositions and finding truth values given the propositions and their logical operators. Let's have another example. So here we go. We have here just only one NOT gate and another AND gate. So here nothing will happen, so this input stream is just already the input to our AND gate. But something happens here because these input streams will have to pass through our NOT gate. And once it passes through our NOT gate, as we can see, NOT 1 is 0, NOT 1 is 0, NOT 0 is 1, NOT 0 is 1. So this is indicating us that for our AND gate, we have the inputs 0, 0, 1, 1, then 1, 0, 1, 0. Again, nothing happens here because there is no gate in this branch or in this edge. So therefore, once we now check this one, we'll have 0 and 1, which is 0. So let's place it in our output stream. 0 and 0 is 0. 1 and 1 is 1. 1 and 0 is 0. So given these input streams, this is the output stream that will come out provided this specific logic circuit. And that's an example of analyzing a simple logic circuit through the knowledge of our propositions and logical operators.